present and solve a differential equation problem, specifically a mixture problem. In line with this, we are here to solve the problem in 5 different ways, namely,
using integrating factor,
using separation of variables,
Picard's successive approximation,
using Euler's method of approximation, using a software called MATLAB. Mixing problems are an application of differential equation. They are more problems that require us to create a differential equation based on the concentration of the substance in a tank. Usually, we will have a substance like salt that is being added to a tank of water at a specific rate. At the same time, the salt-water mixture is being emptied from the tank at a specific rate. We usually assume that the content of the tank are always perfect mix, and we are asked to model the concentration in the tank at a certain time.
So here's a mixing problem with regards to the differential equation. A tank initially contains 100 gallons of fresh water. A mixture containing a concentration of 1/2 pounds per gallon of salt enters the tank at a rate of 2 gallons per minute. And the well-stirred mixture leaves at the same rate. So the question is, find the amount of salt at any time t and find the value of salt after 10 minutes.
So before we engage in solving the problem, let us analyze it first. So, a tank initially contains 100 gallons of fresh water. Which means that it has a volume of 100 gallons. And according to the problem, it contains a pure fresh water, which means that the initial concentration of the mixture in the tank is equal to 0. A mixture containing a concentration of 1 lb per gallon of salt enters the tank at a rate of 2 gal per minute, which means that Qi is equal to 2 gal per minute, and the Ci is equal to 1/2 lb per gal. And the well-stirred mixture lives at the same rate, which means that Qi and Qo is equal. So the only unknown variable is CO, which is the concentration. So we are required to find the amount of salt at any time t and find the value of salt after 10 minutes.
So for this problem, we will solve it with the method of integrating factor. So the equation of integrating factor is dq over dt equals the rate in, which is C1 Q1 minus rate out, which is CO QO. So substituting the given values, we will have dq over dt, which is equal to C1, which is 1/2 multiplied by Q1 2 minus, since we do not have value for CO, we will get it by having an equation of Q all over V initial plus the difference between Qi and Qo. So QI minus QO T multiplied by Q sub O, which is 2. So we can notice that we will have a cancellation in here. So we will cancel 2. So V initial is equals to 100. We can notice that 2 and 100 can be cancelled. So this will be equivalent to 50. So we will have dq over dt is equal to 1 minus q over 50. So with this given equation, we can transform it into a linear ODE. So dq over dt plus q over 50 is equal to 1. So solving for the integrating factor, we will have dq over dt plus q over 50 plus 1. So solving for the mu of t, we will have e integral of p of t dt. So in this equation, the p of t is 1 over 50. E raised to integral of 1 over 50 dt. So simplifying the integral, we will have e raised to 1 over 50 t. This is now your integrating factor. So let's proceed to the q of t. So for the q of t, the formula for it is equals to the integral of mu of t g of times g of t dt plus c all over mu of t. So substituting the given values, we will have mu of t is equals to e raised to 1 over 50 multiplied by g of t, which is equals to 1. Since e raised to 1 over 50 t times 1 is just e raised to 1 over 50 t. So let's just disregard the 1. So plus c all over e raised to 1 over 50 t. So solving for the integral, we will have 50 e raised to 1 over 50 t plus c all over e raised to 1 over 50 t. So let's put the e raised to 1 over 50 t into the numerator. We will have q of t, which is equal to 50 plus ce raised to negative 1 over 50 t. So since we have an initial condition of q of 0, which is equal to 0, let's substitute it. So 0 is equals to 50 plus ce raised to negative 1 over 50 times 0. So since we all know that any number raised to 0 is equal to 1. So e raised to negative 1 over 50 times 0 is just 1. So we will have 50 plus c. So the value for c is negative 50. So we will substitute the value of the constant c, which is equals to negative 50, to the q of t. So substituting q of t, which is equivalent to 50 minus the constant c, so negative 50 e raised to negative 1 over 50 t. So since we wanted to know the pounds of salt after 10 minutes, so we will have when t is equals to 10 minutes. So we will have Q of t, which is equivalent to 50 minus 50 e raised to negative 1 over 50 multiplied by 10. So the calculated value is equivalent to 9.063 LB. So this is the value of the salt after 10 minutes. That's all.
So the second method we'll be using to solve the problem is separation of variables. So the main equation to model this situation is the rate of change in Q equals the inflow, which is C concentration entering, and the QI minus CO. So substituting the values we got from the problem, we have C1, C inflow is 1/2, and the Q1 is 2, minus CO, which is the unknown, and the rate that the solution is leaving the container is 2. To find CO, we have the formula Q over the total volume, which can be written also as Q over plus Q minus QO times N. But this is 0 because the inflow and the outflow have the same rate. So we know that Q is the unknown and the total volume is 100. So substitute this to CO. We have Q over 100. So simplifying, we have dQ over dt, Q over 50. So the next step is to multiply both sides of this equation by 50. It will become it will become 50 dq over dt equals 50 minus 2. So rearranging this formula will come up to this equation, dq over 50 minus q equals dt over 50. And integrating both sides, we will have ln 50 minus q equals 1 over 50 plus c negative. So it will become, since this is negative, transpose negative to the other side, it will become ln 50 minus q equals negative t over 50 plus c. Exponentiating both sides, we'll have e raised to ln 50 minus q equals e raised to negative q over 50 plus c. So it will become 50 minus q plus c. Or we can write this as 50 minus q equals CE raised to negative P over 50. Transpose 50 to the other side, we will be having negative Q over negative 50 plus CE negative P over 50. Then it will simplify further. We have 50 plus CE negative P over. Simplifying further, we will have Q equals 50 minus CE raised to negative P over. This will serve as our general solution. But since the initial condition is Q of 0 is equals to 0, we have 0 equals to 50 minus C e raised to negative 0 over 50, which will become e raised to 0, but e0 is 1. C is then negative 50. So the solution will become Q equals to 50 minus 50 or plus 50 e raised to negative p. So since the problem is asks to find the value of salt after 10 minutes, we will set t as 10. Then substitute 10 and t in this equation. It will become Q plus 50 plus 50 e raised to negative 10 over 50. The value of salt after 10 minutes will be 9.0635.
So the fourth method that we will use in solving this problem is all about Picard's method of successive approximation. And according to the previous method, we can create or form a DE from this dP over dt is equal to Ci Qi minus Co Qo. And according to the previous method, the DE that was formed is dQ over dt is equal to 1 minus U over 50. And we will apply this DE in the Picard's method of successive approximation. The first step, we know that the initial value is Q of 0 is equal to 0. So P1 is equal to integral of the DE 1 minus Q over 50 ds. And we will substitute S into the Q. P1 is equal to 0 to T integral of 1 minus Q over 50 from 0 to T ds. And according to the initial condition, Q0 is equal to 0, which means that the value of this is equal to 0. And we can form that the P1 is equal to integral of 1 ds from 0 to t. The integral of this is Q1 is equal to S from 0 to t. And Q1 is equal to T. And next is we will find the second P or P sub Q P sub 2 is equal to integral of, we will copy the dE, 1 minus, we will substitute this to the cube T or S over 50 ds from 0 to T. And phi sub 2 is equal to S minus S squared over 100 from 0 to T, which is equal to T minus T squared over 100. And after this, we will find the P sub 3. We will substitute this, the value of this into the dE. P sub 3, P sub 3 is equal to integral of 1 minus S over 50 minus S squared over 5,000 ds from 0 to T, which is equal to S minus S squared over 100 plus S cubed over 15,000 from 0 to T, which is equal to T minus T squared over 100 plus T cubed over 15,000. In order to find the quantity or value of the salt after 10 minutes, we can substitute the 10 minutes, which is the time from this T, so that we can approximate its value. And by doing it, ten minus 10 squared over 100 plus 10 cubed over 15,000 is equal to 9.06667. And we can say that its value is approximate, and it is not very accurate because we are just approximating its value using the Picard's method.
Another method for solving this problem is Euler's method of approximation. So, we all know that the differential equation is dq over dt equals 1 minus q over v. So for this method, we will assume that we have a step size of 2 minutes. And we are asked to find the value of salt after 10 minutes. So we will make a table. First is our q sub 0, q of 0 equals 0. Since our step size is 2 minutes, we will add 2 in our t sub 0. So our t sub 1 equals 2 until we reach 10 minutes. T sub 2 equals 4, t T sub 3 equals 6, T sub 4 equals 8, and T sub 5 equals 10. We will find the value of Q sub 1 to Q sub 5 to find the value of salt after 10 minutes. So for the formula of Q sub 1, it is Q sub 0, or the previous value of the Q, plus the differential equation 1 minus Q over 50 times the step size. It is equal to 0 plus 1 minus 0 over 50 times step size 2. Calculating this, it is equal to 2. So for our Q sub 2, we will have the previous Q, which is this one, for our Q sub 0. So it's like Q sub 1. So 2 plus 1 minus 2 over 50 times 2 equals 3.92. For Q sub 3, just do the same. 3.92 plus 1 minus 3.92 over 50 times 2 equals 5.763. For Q sub 4, 5.763 plus 1 minus 5.763 times 2. It is equal to 7.5327. And for the last Q sub 5, 7.5327 plus 1 minus 7.5327 over 50 times 2, it is equal to 9.2314. So this is our value after 10 minutes. As we notice, the value that we got has a small difference from the actual value, which is 9.063. It is because our step size is large. To get the most accurate or closest value to this 9.063, we'll have to decrease our step size. So we can conclude that the smaller the step size, we'll get more accurate value.
Okay, so aside from the four methods presented, we could also solve the problem using MATLAB. So the problem is, a tank initially contains 100 gallons of fresh water. A mixture containing a concentration of 1/2 pound per gallon of salt enters the tank at a rate of 2 gallons per minute, and the well-stirred mixture leaves at the same rate. Find the amount of salt at any time and find the value of salt after 10 minutes. So the first thing that we're going to do is to create the variable. So seems Q sub T. So Q sub T will be equal to the amount of salt at any time. The next step is to create the initial condition. So the syntax for it is CONT_1 equals Q sub 0 equals 0. This means that the amount of salt at 0 minute is 0. With this, we can now input the solution that we discussed with the previous method. The syntax is Q sub T is equal to dsol parentheses dq is equal to 1/2
multiplied by 2 minus 2 skew of t minus 1. As we can see, we now have the solution for the amount of salt at any time, which is 50 minus 50 multiplied by e raised to negative t over 50. So we can now solve the last part of the problem, which is to find the value of salt after 10 minutes. So we're just going to input the following syntax. Q10 is equal to sub Q of t, comma, t minus 10, comma 10, and enter. So the answer is 50 minus 50 multiplied by e raised to negative 1 over 5. Also, this is also equal to 9.063 pounds. That is all.